Now next topic, that is equilibrium of particle. The condition in which the net external force acting on the particle that becomes zero, then it is called equilibrium of forces. So if two or more than two forces are acting on the particle, then the net force or resultant force acting on the particle, that is the vector summation of all the forces. And when this vector summation of all the forces that is equal to 0, then we can say the net force of all the external forces acting on the particle, that is 0, and now we can say the particle is in equilibrium. Now see here, equilibrium means what? When net force is acting on the particle is 0, it implies that as per Newton's first law of motion, we can understand this thing. If the particle is stationary, then it will remain stationary. Or if the particle is in motion, then it will continue it with uniform velocity. Means in both the cases, the acceleration will be equal to 0. Now see here, net force acting on a particle, that is nothing but vector summation of all the forces, that is equal to 0. Clear? So here equilibrium, for equilibrium sigma f, that is equal to 0, then we can say equilibrium will be established. So we have to take the vector summation of all the forces to find out the net force. Suppose we consider three forces are acting, then in that particular case, here the summation of x component of all the forces, that should be equal to 0. Summation of y components of all the forces should be equal to 0, and summation of z components of all the forces should be equal to 0. Then and then only the vector summation of all these forces will come to 0, otherwise not. Now here suppose we think about two forces acting on a particle, F1 and F2. Now when two forces are acting on a particle, then what will be the condition for equilibrium? So vector summation of F1 and F2, that should be equal to 0. It implies that F1 plus F2 equal to 0. So we can write mathematically F1 equal to minus F2. So in other words, we can say when two forces are acting on a particle, and if these two forces are equal in magnitude and opposite in direction, as shown in this figure, then and then only there will be the equilibrium of particle, because in that case the net force acting on the particle will be 0. Suppose three forces are acting on the particle. Then when three forces are acting on the particle, then if we take the vector summation of all these three forces, F1 plus F2 plus F3, then for equilibrium that should be equal to 0. So here the vector summation of any two forces, that should be equal in magnitude with the third force, and that should be in the opposite direction of third force. See here, this one is force F1, this one is F2, this is F3, and on this particular particle these three forces are acting. So here these three forces are passing through a common point. So when all the three forces are here to the common point or acting at the same point, then the forces are known as concurrent forces. Then see here, if we take first F1 plus F2, then magnitude of F1 plus F2, that should be equal to magnitude of F3, and F1 plus F2 should be in the opposite direction of F3. Then and then only the resultant force will be equal to 0. And here, if we think about the equilibrium of particle when more than two forces are acting, at that time we can observe this thing. If we take the vector summation, then in graphical method, if you remember, we discussed this thing. To take the summation of the vectors, we arrange the given vectors head, tail, head, tail, head, tail, head, tail. So, if more than two forces are acting on the particle, and if we arrange them in head, tail, head, tail, head, tail manner, then definitely it will form a closed loop. And if all these forces acting on the particle are arranged head, tail and form a closed loop, then we can say this thing, the resultant of all the forces will be 0 and equilibrium of the particle will be there. Now, here we can represent this thing in the broad sense like this. If n forces are acting on the particle, then if vector sum of all these n external forces that is equal to 0, then the equilibrium of particle that will be obtained. Clear the concept of equilibrium?